turning data into meaningful insight. Yeah, and also the experience has greatly impacted me by helping me like understand how to uh, import images and like it has like I learned a lot. I cannot mention everything. Yeah, thank you. And I'm really grateful to be part of this cohort. Yeah.
All right, you are welcome, Dauda. On behalf of Lecture Hub, we are so glad to hear the feedback, the positive feedback. It's kind of encouragement to us and kind of, when you are doing the right thing and people are commending you, it will give you this energy, this strength to continue doing it, right? So thank you so much for the feedback. So moving over to the next person, Akimu Odunola. Please, can you go ahead? Akimu Odunola. I'm sorry if I'm not pronouncing it correctly. Can you go ahead, please? All right. So, Chibeze, are you back? Can you hear us now? Okay. Falashade Ojo. Please go ahead and tell us your name, what you have achieved so far. That's how the mentorship program has impacted your life. Thank you.
Miss Mary Jane, my name is Falashade Ojo. So for the internship program, I've really gained a lot. Even though I think I joined halfway. So the first day I joined, I learned some things about strings and how to convert different types of data types to the order. And yeah, I've been learning data science for some time now. I don't really know much about the directory of functions. So through the program, I was able to know that when you want to know more about your functions, you check the directory. From the directory, you'll be able to know what and what you can play around with the functions. So other thing that stood out, that was that should be the third class. Yeah, that was when how we can um to convert our core images into different parameters like to know the depth of the well. From that you'll be able to the engineers will be able to know the depth at which each of the cores are being taken from. Yeah. So I think yeah, that's one. Another thing, how to view images too. I didn't really know about the library that this other library that we used to pillows. Yeah, I didn't really know about pillows before. So yeah, it has been a worthwhile journey, the internship, and I really enjoy it. I must confess. And aside that, I love the fact that the facilitator, our mentor, the way he charged us, when I was watching the video, the recordings, the way he was saying that, oh, comparing us with those of Chinese, how you don't need to cajole them to learn. They are always ready to learn and also ready to develop things. That's really, really challenged me a lot. And yeah, I will take it. I will take his word and I will act on it. Thank you very much for organizing this and so I'm moderators.
All right. Thank you so much, Falashade. We really appreciate the feedback. Thank you. And I will still say the same thing is encouraging, and thanks to Lecture Hall and also thanks to our mentor. I'm glad you're able to learn and achieve all of the things you have listed. So yeah, thank you and you're welcome. So let's move on to the next person, Olayemi Samuel Ogundele. Can you hear me? Please unmute yourself and tell us your name, how the mentorship program has impacted your life so far. Thank you.
Yeah, good evening, everyone.
Good evening.
Sorry, I don't know that it will get to my turn this fast. Actually, doing something else. So, yeah, thanks to Lecture Hub and facilitator. So, it has been a wonderful learning experience for me personally. Though some of the things I'm a bit familiar with them, but two things actually stood out for me, which I underrated before now. So there was a time I've been using virtual environment, and the question came up in my place of work that why do I really use that in one of my projects? So I struggle, I struggle to answer that question. But during this training now, I've been able to see the why and the reason, the why I'm using the virtual environment. And with my eyes closed, I can create as many virtual environments um, as possible. So also another thing that stood out for me is creating a file path, because it's very, very different to have a file inside a folder. So how do you get to create a file path for that folder for it to be accessible to you? So though we work a lot with images, so how do we make sense of that image so that we can actually locate it in a folder? So that actually stood out for me too. So thanks once again, thanks to Lecture Hub and for making this happen and to facilitate. That's all from me.
All right, Samuel, that it's wonderful hearing all those comments from you. You're welcome. On behalf of Lecture Hub, I will say welcome to you too, okay? So thank you so much. Then moving over to the next person, Oluwa Ferami Ikade. I don't know if that's the correct name, but please kindly unmute yourself, tell us your name and how the mentorship program has impacted your life.
Good evening. Good evening, everybody. So, how has the class impacted me? Although I started as a beginner, like I have zero knowledge of data analytics and data analysis and Python, all of that coding. So I've been able to learn how to create an environment, and now I can actually work around different data, even be it the well data, when even if not the core data that was explained, I can now create it, I can now activate it and work around, see how possible. And my job as a geoscientist, I'll collect the data and make it easier for the other other scientists to work on and know what the data contains. So I can now import data, and I know some libraries now too. So it has been an interesting one and an impactful one too. And the mentor too is as simple as ABC. Like he explained it starting from the data type and all sorts. So I'm grateful to Lecture Hub. Thank you so much.
Okay, thank you so much. It's quite interesting how you came as a newbie and you're able to acquire all this knowledge. It's really, really encouraging, and I will tell you to keep it up. Keep it up. It's not easy, right? Being a newbie in data analytics or data science, and here we are trying to use that same knowledge to visualize our reservoir. And here you are being able to grab a lot of things. So yeah, you are doing well, and I'm proud of you. So you're welcome. You're welcome. On behalf of Lecture Hub, you are welcome. So yeah, let's move to the last person here, Samuel Ogidi. Samuel, please kindly unmute yourself and tell us your name and how the mentorship program has impacted your life so far. Thank you. Samuel, please, can you hear me? Okay, Samuel is actually not the last person. So I'm seeing, but I'm not seeing the name. I'm seeing a Zoom user. So please, if you are the one, kindly unmute yourself, tell us your name and how the mentorship program has impacted your life so far. Okay, Zoom user, if you are speaking, I'm sorry, but I can't hear you.
Okay, can you hear me now?
Yes, I can hear you now. Go ahead.
Okay, good evening. My name is Benkishia Maimuna Hadi. And okay, a big up to Lecture Hub actually for this mentorship program. We really appreciate cause actually for me, it boosts my confidence level on data analysis using Python because I've not been able to navigate myself using the Python, the VS Code, yes, or Jupyter Notebook. But then I've been able to do so, like more on a beginner intermediate level do. And also, I like the fact that we used geological data. I think this is the first time I was using Python for analysis related to my field of study, geology. I am very grateful for that. And then I've been also able to like know some functions and then the libraries, NumPy, Panda, and other libraries. I've been able to access them, importing of data and other stuff. Thank you to lecturer, thank you to the lecturer, and thank you to you too.
All right, thank you so much. I think we have something in common, being able to witness geology datas. Just like you said, I've not seen where they use geological data, that's the core samples, core images to work on a data science or data analytics. But being a part of this mentorship program, I was able to see that. It seems like they were referring to me because I'm a geologist and I understand data. I was like, wow, so I can actually do something like this. So we can actually do this. So yeah, it is very, very interesting and it was an impactful journey and it is an impactful journey so far. So yeah, you are welcome. You are welcome. So I'm seeing someone on the call, Joshua. Okay, we are discussing how the mentorship program has impacted our lives so far. So I don't know if you can hear me. You have the opportunity to go ahead and tell us your name and how the mentorship program has impacted your journey or your data science or data analytics skills so far.
Okay,
You can go ahead.
good evening, everybody.
Good
So,
evening.
I'm Joshua Salvation in Benedict. So, I've done a lot actually with Python before, but coming on board this particular program, I had the opportunity to actually work on geological data, as someone likely said. So, though I've been using Python before, but
Okay, Joshua, sorry, your mic is breaking. I don't know if you're. Can you hear me? We can't hear you because your voice is breaking. So
okay,
if you're trying to use a headset, you can remove it also. I don't know what's causing it.
I believe you can hear me now.
Yes, yes, it's perfect now.
Okay, so I said joining this program actually gave me the opportunity to work on geological data sets, like someone rightly said. I said, though I've been using Python for a while, I've done a lot with Python, but I've not actually used Python on any soft surface um, work or reservoir related work before. So coming on here, I had the opportunity, at least it gave me an insight, and I believe this is just a startup for me because I know I still have a lot to go using Python for my subsurface analysis. So that's it for me.
All right, Joshua, you're welcome. We are proud of you. So, okay, I don't know if Chibeze is willing to say something or if he's still on the call and the other person. But before then, in case Chibeze, if you want to say something, you can raise your hand. So I'll be handing over to Mafejiro. She's on the call. Since today is our last day of our mentorship program, since today is the last day of our mentorship program, I'm going to hand over to her. I believe she has some things to tell us. She also for us to know if we are going to partake in a project, because other mentorship teams, they had project during their graduation day. So I will hand over to her. I believe she has a lot to tell us. Okay, she's currently on transit, so she'll be coming in later, maybe after our mentor. So Chibese, you can go ahead now.
Good evening, everyone.
Good evening.
Okay, my name is Chukwu Chibueze Godwin. So through this mentorship program, I've been opportunity to use geologic data because I've been using other data, but this time around I'm opportunity to use geologic data because I'm a geologist. So the mentor has been doing a great job. He's taking the class gradually, even beginners are catching up. It's really a great one. And I want to use this opportunity to thank Lecture Hub for this opportunity because I've been looking for how I could integrate what I know in Python and data science to geology. But this program now has bridged the gap. I'm really grateful.
All right, Chibese, you're welcome. So looking for the other person, I think, is it Akimu? Were you the one we skipped? Are you ready to say anything? Are you ready to say something? Okay, all right. So I'll be moving over to the next thing. So I'll be dropping attendance list on the chat box. So it will be very important that everybody, every one of us. So our last class, I found out that there's this particular person. I don't know if it's just one person or two that did not write the attendance, and they were in this call from beginning to the end. I don't know why, but I don't think there's anything I can do if you did not write your attendance, because that's one of the criteria that will determine if you will get a certificate for this particular mentorship or not. So please, whenever they say something that you should do this, try and do it because it's going to help you, right? To avoid confusion or misunderstanding at the end, always try to do the things they ask you to do. So please, I would like us to drop our attendance on the chat, but I think we are going to do that for 5 minutes. Our mentor is ready. So just do it for 5 minutes. And this class is not going to take much time because it's a closing part and he just wanted to touch the things he could not touch during the other classes. So it's not going to take long. So we'll just use 5 minutes and write attendance. Okay? All right, please use the same format Oluwaferami used to write your attendance, please. And we have 4 minutes left for it. Thank you. Okay, for those of us that is joining now, we are writing attendance. So kindly go to the chat room, chat box, and write your attendance. And we have 2 minutes remaining. All right, without wasting much of our time, the attendance is still going on, so you can always go and write your attendance. It's very, very important. And please try and follow the format in writing the attendance, okay? Thank you. So our mentor is here already, and he's ready for us. So I'll be handing over to our mentor, Mr. Divine Okon. Good evening, sir. Please, can you hear me?
Yes, I can hear you. So I owe you guys an explanation for coming late. So, but on one condition, you guys will off the microphone, because if I tell you now, it will be recorded. So if you agree, you off the what's it called, the recording, before I tell you. But I'm really sorry. I was in the neighboring country, so I went for something that I can discuss when the recording is on, because it will be there forever. So
All right, sir. It's fine. We forgive you.
okay,
We
thank you.
forgive you, so you can go ahead with the class. Thank you, sir.
God bless you. Thank you for giving me. So today we're just going to jump in and just quickly just finish up the stuff. I'm trying to connect to my monitor, but I think I'll just use my, let me see, share. So quickly, I'm just going to, I think okay, good. I think we're good here. Sure, so I was looking out for open source Postgres hosting services, Then I remember the one I used, when I was working for one guys like that. We used it to collect and store data for a delivery application. So I figured, okay, we can use that one. Because if we start setting up Postgres now, it's not like it cannot be done, it can be done, but I'm looking at the timeline. Like I'm looking at what we're going to do before we start writing SQL codes. But for those of you who have downloaded Postgres, like you guys are the real G's. In fact, anything I'm doing here, you could replicate it in Postgres. But the problem is how you import data will be different. This is an open source Postgres machine run by a company called Superbase. I think Superbase, I still have subscription. So Superbase Postgres. If I were you, I would okay, that's it. I think I already have an account, so I'm just going to sign in. So this would help, like this would make life easy for you guys. If you have a GitHub, you could actually just sign in with GitHub. Let me see if I can remember my account. So the sign up is the same thing. You just have to sign up. I'm just going to show you what we're going to do with it. It's pretty much easy. Now, the good thing about Superbase is I think most companies like it because one, it runs in the cloud. At first when you sign up for Superbase, what happens is they give you, I think, about 50 gigabytes worth of space to store data. After then you start paying. But the downside to that is, first of all, your whole data infrastructure you're developing it on a third party's platform, so that's kind of risky. But it's still the same thing. What most companies do is they use Postgres, host it on their own machine. So they have limited space and resources they want to use to actually work around with Postgres. But Superbase, everything is on the cloud. So basically, you're actually being paid. You pay for the space you use. The Postgres version, just like Azure, just like I think Google has BigQuery, the same concept, So I'm just going to sign in with Superbase. I think I'm trying to look for my password. I think let me come down here. Password. Okay, here I think I found it. Photos. So I think my email I used then was at gmail.com. Now, why this is really important is why Superbase is really cool is the fact that you might not need the setup for Postgres. It's kind of complex when you're doing it. Okay, I'm going to explain something. Just give me 1 minute. So there's something we call on-prem and off-prem. It's basically when we say something is on premises and it's on, like if it's on premises, that means the setup is done locally. Now, when it's not on-prem, that means it's in the cloud. So I'm coming. Let me just log in before I talk plenty. Okay, don't remember my super base shift. Don't worry, let me see if I got it properly. But I can't show password, that's the problem. I hope it's correct. Please just work, please. Invalid login, I think. So I remember. Let me see if I can type somewhere, then put it back. Oh, you can steal my password. There's nothing inside there. I think that account, it's bullshit too. My super base. No, I think that's not the one I use it. Yes. I think this should be it. If I come down here and I put it here, and hopefully this works. Invalid login credentials. So, okay, let me just sign up so that we just do it together. So, not now. I'll just sign up. I think it's gonna be easier to sign up. Okay. Oh, can you see what I'm doing? I'm supposed to sign in, not sign up. See my life. So this is. Sorry, it's been a long flight. This is signing. I think this will work now. It's not the same. Guys, please just forgive me because my super base. Yeah, that's it. Control C. The tribunal180@gmail.com. That's it. Oh, okay. I'll just sign up. Not now. Email. Let me use this one. I hope I. Oh, okay. I think I know what my problem is. Guys, I'm sorry. I'm sorry. I'm sorry. I think I remember the password now. If you can sign in, like sign up, like while I'm doing it, you could quickly just to sign up. It's not difficult to sign up. It's just me forgetting the password. I hope this is the password because now hopefully this is the password. Please just work. Please. Please. Yep. I haven't created a lecture hub. I think because yeah. Good. So so I'm going to just start a new project. It's the same thing. So I was playing around with this today, just basically to get it sorted out. So I'm going to do something here. Now, if you go to Supabase, you're going to see something like this. So I'm just going to explain how it works. So there's a SQL editor. In fact, forget about that. Always come down here. So you have the table editor, you have SQL editor. This is basically where you write your SQL query, select, blah, blah, blah. But you have to have data to write it. Now, the next thing next is database. Now, I was trying to just walk around with the database, but what's going to happen here is we're going to import new data into the database. This is a public schema. You could create your own schema. Now, what is schema? So I'm going to explain how database system works. So I'm going to start with the simple logic. Why we're using Supabase? What is Supabase? When we say something is on-prem, what does it mean? When someone says something is, cloud hosted, what does it mean? So I'm just going to make a simple explanation. It's not complicated stuff, so you understand it. So the first thing I'll tell you is, now Supabase is, a cloud solution. That's exactly what it is. What they do is they exchange, you pay for their services because of what's it called? Space. That's basically what it does. But because they know that you're not just saving just files, they built in a Postgres database into their platform. So that what happens is, since you'll be storing, structured data into their database, they charge you for the space. That's all they charge you for. But apart from that, the whole editor and stuff like that, you could actually use it for free. Now, we're using the free version of Supabase. That means we have access to basically everything. The only thing we would pay for, and if you want to use Supabase for production, it's when you're handling a lot of data. Maybe if you're building an app and you want to, your backend or your database, Supabase will handle your database. Good for you. So what happens is Supabase can actually charge you, for the amount of data you're using. Now, this one is off-prem. It's not. So on-prem is basically what you're doing now. You downloaded Postgres yourself using the space in your own machine, to process the data in the machine, in the database. So Postgres is like a service, a software. What you have to do is you mount it on your own machine. So Postgres uses the space on your own machine, to process the data. So that's the difference between both of them. So if you don't have space on your machine, it's the possibility you can actually process the amount of data you want to process on Postgres. So what you're having basically is a software installed in your machine using, the space in your machine to process data. So now the trade-off here is Supabase is easy. What I mean by easy, the whole configuration of database, you don't have to do that, it's a plug and play. You design your schema, you walk around with you design your schema, you walk around with the tables in your schema, and it's just like that. Life is easy. You write your SQL code to actually analyze your data. You download your sheet, whatever you want to do, you could do it all in one platform, and it's really cool. So, and also too, with Supabase, the configurations, like using APIs, it's very easy because already on the cloud, so really easy. Unlike Postgres, you have to host your database on a server before you start, using, APIs or building APIs that could actually talk to your database. So with all you don't have to do that on Supabase, it just makes life easy for you. So that's really cool. But the most important thing is, if you're working for any company, nobody will tell you to come and, configure databases. That's not your job. We have database team that will handle that, database system admins that handle those kind of stuff. Your job is to give you access to the database, and the next thing you're going to do is basically play around with, the data stored in the database and analyze it, or importing data into the database, and work with it. So it's just an easy way to look at it. So the first thing we're going to do here is basically understand what we need to do. So we need to, before we walk around, we need to import data into the database, right? So, and how do we do that? Now, click on table editor and questions. Now we have already, I imported this just for test. So what I'm going to do, I'm going to see if I can delete this, delete table, and table is deleted. I don't need this. Now, the next thing I want to do here is I want to create a new table. So I'm going to explain what a table is, what a schema is. So just imagine you have a file system on your machine, on your desktop, and you want to create mini folders inside that file. Like, so you have a folder, you created a folder on your machine, and you want to create mini folders inside that file. So that's how schema is. So a schema is more like, the big folder that holds small folders inside the file. So you can have a schema, and that schema can be we can define a schema. We can see that schema is geophysics. Now, that means every table on that geophysics schema would handle geophysics data. So inside that schema called geophysics, you can have seismic that collects what's it called? That collects seismic data. And seismic data is to like, okay, yeah, you can have electromagnetism that collects electromagnetism data. But the problem is you have to define it based on the type of data you collect. So when you say electromagnetism, what does it really mean? Or if you say electricity, what does it even mean? Like in geophysics. So you have to define it, So if you say seismic and you create a table and you say, okay, that table is collecting a two-way travel time data, so it's stored inside. So you can have tables, lots of tables stored inside a particular schema. You can have different schemas, in a database, and inside of those schemas, you have multiple tables inside of those schema. So you could actually call data from a schema, connect it with a join, You can join multiple table, just to get data, and you can join multiple schemas, just to get data using their foreign key and their primary keys. So these are things you're going to learn, self-learning when you want to learn, SQL database. It's actually really interesting. You see how it works. Now, imagine I am dealing with core photos. With core photos, I can have, let's say I want to put them inside a schema called petrophysics. Now, I have a schema called petrophysics, and that petrophysics, I have what they call, inside that petrophysics, I have what we call, let's call it core images. Or let's say core photos table. And you're storing core photos like the way we're going to store it pretty soon inside that table. And you have another table now called, maybe called interval. You're storing the intervals of those core inside. Now, and remember, all of them comes with their depth. And you want to basically just understand, okay, at what depth do I have this core photo? So you can join the core intervals, with the core photo table, using a join key, a join parameter, based on their depth. And you can actually see how the depth align with, each of the core photos based on the interval. So you could actually see. So there are different ways you could play with database if you store the information in database rightly. So it's kind of really tricky. It's not really tricky. It's kind of interesting. So the first thing first we're going to do with these guys, let's say we're playing with a public schema. So I don't have a lot of time to start. A public schema is just the schema it comes with. So you can create your own schema if you want. So I'm going to create a new table. And you could see I could decide to what's it called? Okay, let me call this core photos. Core photos. Then I describe it. I see it lecture. If I were you, I'll spend time playing with lecture hub series, core photos, database, whatever it is. I don't know what that is, but I don't care about the real time. So the next thing here I want to do is basically add column. Now, there are different ways to do it. I could basically add column one after the other, or I just import the CSV. Now, I'm going to explain why. In Postgres, you have to add the column manually first. Store the columns like in the table first. Any questions? Someone see something? But I don't want. I have time to answer your questions today. I have time with you guys. So I could just click on this guy to add column. So what happens is I keep adding columns one after the other. Can you see what's happening here? So here, the first one I have an ID. The next one I can have another column. I could call it what it is, created at. The next one I can call it file path. Are you getting me? And as I'm doing that, I am choosing what's it called? The data type. I'm going to explain what data type is. We already explored that a little bit. Or for this guy, you could just import a CSV. Are you getting me? Browse through your machine and find the CSV file that you want to add. So we're going to approach it with the second step. The first step for Postgres users, very important because, like I said, you're not designing databases, so it doesn't concern you. You wouldn't have to design all this process. So now we're just going to come down here to the code base and see something. So remember, in this data, we have it in Excel already. So we have the path. So I'm just going to run this guy. And I come down here. And in this guy, what I have to do is basically, first of all, know the columns. So now these are the columns you're going to use, go there and keep adding one after the other. So when I say file path, what data type is file path? So the best way to actually understand this is basically do something like this, df.info. and this will help you understand what you're doing. So when you do dev.info, it basically tells you what data type if you process the stuff properly. Now, here it's basically an object, which is basically text. So when I mean an object, it's non-numeric, far apart. Here is a well name, obviously, is a text, which is basically non-numeric. Postgres or any database system interprets it like a text. Now, top depth and bottom depth, we call it depends on what you call it. If it's a decimal, you call it a float. You could actually save it in the database as a float or as as an integer, depending. So, but for me, this would basically help you know how you want to define or it doesn't even have to help you know. Most times, if you're working for an organization, I'm sure they already have databases, No, I wouldn't say that. Because imagine you want to work for a small servicing company, it's more like as an internship, and you really want to help them. Most of them don't even have database. Setting up something like this can actually help them. Storing data, structured data cleanly on their database can actually really help them. Now, I'm just going to show you something. So quickly, I could basically just come here and say, okay, the next thing I'm going to do is database only takes CSVs. Now, I'm going to explain what CSV means. CSV means comma separated variable. So CSV, it means comma separated. You already know that already. Separated variable, if that's correct. So what it simply means is Microsoft invented Excel. CSV is default, for every machine. It simply means that if I create a TXT file and I separate each of my information by comma, and I convert that to Excel, what happens? Each of those comma is created as a line. That's what it simply means. Now, Microsoft in their own wisdom and engineering ingenuity created Excel, a better way to actually, manipulate what's it called? CSV. So Excel is a software, unfortunately. So CSV is default. So the first thing you do here is basically you come down here and save this information as a CSV. And how do I do that? So I could come down here and I can do pd.to CSV and not PD. The name of my data frame is called df to CSV. So I can choose a file path where I want to save this information. So I can come here and I can just choose, I think I have something called lecture hub classes. Yeah. So that's it. So let me see if I could just access lecture hub classes from my okay, so CD, I think lecture hub classes, if I have it somewhere here. So lecture hub class, I could just copy it and just keep it here. And I do PWD. So automatically, this gives me lecture hub classes. Now, if you're using a Windows machine, it makes life easy for you. You don't have to come and do all this bullshit. You just have to. So I could just quickly just put an arrow in front of it and just paste this guy here. And I say I want to save this guy. Core information. I call it core photos processed. But CSV. So I usually like putting index false, and I'll explain why. So why I put index false is simple, so that the indexing will change. It will align to the index of the CSV file, not it won't go with its own index. Index simply means this stuff 0, 1, 2, 3. So what happens? It aligns with the index with the CSV file you're saving it with. So if I save this guy automatically, I have a CSV file saved. Now I go back to Superbase. And in my Superbase, what happens in my Superbase? I just have to browse this information and I go to my desktop and I'm looking for lecture hub class. And you can see I have core photo process. I click on it. I want to save, I want to upload this. So you can see the first thing first is uploading this file. That's what it wants to do. So all I do is just click on save. So one in table should have at least one column as primary key. Thank you. Let me click on save. I don't care about the creating new table. Adding 4 columns to core photos. And yes, good. I already have my information. So you could see I have been able to save this information here. So you could see my far part, my well name, my top depth, and whatever it is. So if I go to the left and right, I could see more information about this. Now, what happens is on this schema public, you've created a table called call photos. Makes life easy for you. So we didn't do it manually by creating each of the table. That's true. So how do we query this guy? So all I have to do is come down here, SQL editor, and I write a select statement, and I do select star, and I do from public, which is basically the schema, then I do dot call photos, right? And I close it. So if I highlight this guy and I run, what happens? You can see it gives me all the information of my call photo, which is far apart. So if I put a limit and I see 10, what happens? It gives me only the first 10 rows. What am I doing? It gives me only the first 10 rows. You see, if I say, okay, I want only the distinct well names. So I can come down here and do select. What am I doing? I use distinct. So what am I using distinct for? So these call photos, from these call photos, I can do, let me come down here and I put from, I'll come back to that. I'll explain what I'm doing. And I do as call photos, let me call it CP. So I can do here, select distinct CP dot, I can choose well name, which is what I'm doing. And I do, and that's it. I just want to see the distinct well name. So to see how many well names I have here. So if I highlight this and run this, everything is correct. It's going to tell me I have only one well name, which is 640. That's the only well name I have in my database. Now, I can say, okay, I want to find out only depth values within a particular range. I come back here to the call photos just to see my data. Everything works very well. So I want to look out for top depth greater than, let's say, depth greater than 5,000. Let's see if we have any of this information. So you could write complex queries. You could join across different tables if you have the table stored into, and you could actually export your result. And this is pretty much fast. It just makes life easy. So I can do select star. And for those of you, the assignment I gave you, you could actually store your information in your Superbase, the far part. So I'm going to explain how I'm going to use like a board now to explain a simple data engineering design, for dealing with images, especially for organizations. So I could come here and do select star from, I could pick out the public call photos, and because I have this information, I can call it CA, and I can say where top depth, where CA dot top depth is greater than, is greater than equal to 5,000. So I close this. So I only want top depth greater than 5,000 in my database. So no rows return. So let's see. I think there's no 5,000. Let's see, greater than 3,000. Let's see, there's a 4,000. Okay, I think I know the problem. I didn't highlight all the SQL. Let me see what happened. So good. So you could see only top depth greater than 4,000. That's what it's going to return for you. So the point is you could play around this stuff as much as you want. First thing first is you have to know SQL, which is really important. Obviously, you can't do this without SQL. Second of all, you need to understand, what the database is, why it's important to store information in database. Now, I know you're going to ask me, how would this translate into, visualizing the data? Now, because you've stored the far part here, you could actually, with Superbase, it's easy. You could actually connect this by creating, you can learn about Fast API, develop an API that could talk to your database, obviously, pick the far part. And most times, if you're running on Azure, okay, let's go to system designs. I'm just going to open a sheet and explain what I'm trying to do. So let me see if I can use a Word sheet and do an explanation. Home, and let me come down new. I could come here to all I use Google Docs so that you can see my screen. I could just explain what I'm doing. So plus, plus, plus. So good. Now, so imagine, so you have your files, right? And in these your files, these are images. Now, you have extrapolated the file path. Now, the whole idea of using database system is simple, so that anybody anywhere can access the data at any point in time. So if you're working for, let's say you're working for a mining company and basically they've collected, let's say they have blasting reports for different depths, whatever it is they want to do, they have those information stored somewhere. And each time they want to access the data, what happens is they have to call someone somewhere to forward the data to them. That doesn't make sense. Are you getting me? But if you have a database where someone can query, to understand, okay, what the blast report shows in based on actual data that have been stored in database, it makes life easy. So someone can be in Brazil, you can have someone working for you in New Mexico, you can have someone working for you in somewhere in Belgium and something like that, basically doing different analysis on the data stored in the database and basically conjuring the same report, the same insight. So now, for us now, we have images we want to visualize stored in the table inside the schema, which we call public. Now, what we do is there's something called blobs. Blobs are basically file storage system in cloud locations. Now, what happens is if you have Azure, you can have access to what they call blob system. What happens? You can actually store that image, all those images we created and stored in those folders. We'll take those folders and import it into a blob. Are you getting me? So what happens is the blob will help us generate, more like a file path for those images that we can access. Now, if we have the file path, that means we can generate file path from the blob storage locations. Now, life is easy. Now, but the file path, we need to store it somewhere. So we store the file path, which we just did now, the file path from the blob location. We'll store it inside the database. File paths and maybe other metadata like the depth of, the well name, we can store. So file path and other metadata. We can store this stuff, we can store it in the Postgres. So this works. Now because the blob is on the cloud, it's easy. So I could basically, query my database to get the file path, and I can take that file path, and visualize my data on real time because the file path of that information is stored in the cloud. And if you understand me, it's not stored in your local machine where nobody else can access. So now it's stored in the cloud. Everybody can access it. So now I don't have to start calling the file part of my machine of the data stored in my local machine. Now I have translated all those things you guys are processing. You take that information, store it in a blob, then save the file part of the blob location on the database together with other metadata. And how do you access the blob location? This is where API comes into play. APIs. How do you access database to APIs? So APIs are APIs. APIs are very cool stuff. It's called application programming interface. It's basically an interface to access, storage locations. So most storage locations basically have APIs. Database have APIs. They give you an API and the API key. You could use it to access that information. So an API has security. Data engineer usually handles, and protects databases. So it's a simple process when you work with it, but as a geoscientist, you might not bother except you want to go far. This is just me giving you pragmatic processes on how this can actually work. Now, I wouldn't have to spend my time. I don't like talking about this. It's when we're building something and it makes sense, because talking about it doesn't make sense. For you, your concern now should be, how do I analyze data? How do I import data, store data? In fact, what you should be working on as a geoscientist is, how do I model geologic databases? That's what you'll be asking yourself. That's a question. In fact, that's what you should be thinking of, sleeping on. You can pick you can just pick one subset. You might just say, okay, you're looking at sedimentology. Or you might say, okay, if you're not a sedimentology person, you can look at paleontology, something really cool. Don't worry, geophysics. You can look at it too, Did I spell this? Paleontology. If I don't spell it properly, please forgive me. So you can look at anything, You can pick petrophysics, anyone. The next thing is, if I model a database, if I model a geology database, how do I import data? So import data into that database. Now, import data. Now, you see what we just did there? We manually imported that data. Can you see what we did there? Where we just had to import the CSV. But imagine you're working with 50 and 100 million rows. You won't do that manually. That's impossible. And you're working across different, you're working on a team. Each of those teams are handling those data, different types of data, and they have to keep importing those data into the database. Now, you will not do that manually because one, you have to set QC conditions, so that in case the data is wrong, you can be able to capture the data before storing database, so that people will not just store any rubbish into the database, and at the end of the day, it's a problem for the client or it's a problem for people who want to analyze it. So, for example, a column that has temperature, somebody will now go and store a text, and import it directly into the database. So you have to, so what happens is, what they do is we build what they call data pipelines. It can be any type of pipelines. For this one, a cool data engineering pipeline is a pipeline that connects databases, to raw data. Now, what you're doing is here, those importation process, passes through a pipeline process that has lots of QC rules to check each of the column of the data if it's correct, if it meets the geological standard. Sedimentology. Before it's being stored into the database. So what happens is the same thing. APIs interact with databases. So obviously, as the API is interacting with the database, which is good, you could actually set up with what's it called? With Supabase or even Postgres, you can actually write a pipeline that could actually help you import data. So you don't have to go to the database. It's just a Python script, You give the CSV a file path. What happens? Your QC, your functions, you write different functions to QC each of the columns of the database. Anywhere the QC fails, it returns an error. You go back and check it. Just like that, until everything passes the QC. Then it just runs automatically into the database. You don't have to manually go and import the data into the database. You don't have to do that. So you have to learn how to code, even if you have ChatGPT, because these processes are tricky, really tricky, because dealing with QC rules, quality control, especially with importing data in database, is tricky on its own. Setting up, most times data engineers handles the API connection and stuff like that. I like working around those kind of things. Modeling geologic database, that's something you're going to do as a geologist, because who else will do it? So what do I mean by modeling geologic database? What do I really mean by that? So what I mean is this. So let's say you're building something in sedimentology, which is a schema. Let's say SEDI. Now, in SEDI, you might decide to have different type of data. Or let me use something really cool. Let's say petrophysics. Now, in petrophysics, you can have different tables. You can have where you store log curves. And this might be different types of curves. You know what the Copy-Refusal log curves? Let me look at the one we usually use. You can have let me just use wireline data. So who knows what kind of curves can we store? Look at my head is wireline data. For example, which one can I put that is quite easy? When I remember, I'll tell you guys. You can have what they call 4 intervals. You can have what they call electrical properties data. can have what they call analysis. So these are basically tables for actual data that can be stored inside, let's say, petrophysics. Are you getting me? So this can be the schema, just one schema. Now, you've created a schema that can hold this information. Let's see, yeah, let's see. I remember one, so like gamma ray logs. You can have this if you want. The simpler. I think wireline logs are still part of the logs. Is it gamma ray logs? Am I getting old? So you can have a couple of, so here you could actually have, let's say you have geophysics. And in geophysics, let's say geophysics, you can have TWT, a table for two-way travel time. You know, which other thing can we store in geophysics? What kind of data can we store in geophysics? No, that's related to, most of them are seismic data, especially when you want to store tabular data. So I think most of them is just, maybe you have two-way travel time. Which other one can you really have? You can have, which one? There's, I think, I can't remember now. So I think let me just leave this one here. When I remember more, maybe I could just ask questions. Let me just come down here. Seismic data, I'm tired of seismic data. Yeah, we have different types of data. Okay, good. So you have gravity measurements, yeah, you have electrical data, yeah, hydrographic data, bathymetric data. So seismic data, I think we can put them as 2W. We can have, okay, we have logs, downhole profiles, which is really cool. Like this is a good one. So basically everything depends on what you want to store, depend on the company you're working with and what they call their data. So you could help basically, where's that place? Where's my super base? So you could actually help companies basically design their database by looking at the kind of data they're interested in. You know, most of the times it's all about how they call, their tables. It's still the same thing. Most company can call, like, they could call a table a different name, but another company call it a different name, but they're still storing the same data. So it's you basically understanding how they store their data and how they want to store it and the name they store it. They store the data. That's how you want to. That's basically what's important. So back to Superbase. Push this guy away and come down to this guy. And yes, so like I said, Superbase is kind of easy. So you could actually help model. So here we have okay. So you could actually come back and go to tables or databases, and you could see now we have a schema, right? So this is inside the schema called public, and inside that public we have a table called call photos, and these call photos have file path, well name, top depth, and bottom depth. So I wouldn't have the time to tell you about this, but you could actually walk around what they call primary key and foreign key. First of all, you could have another table, somewhere. And how do you connect that table to that table? So obviously, usually you have to generate IDs for each of, that's what we're trying to do in the other class, where we have to generate IDs for each of the images, so that when we store it in a database, we have unique IDs for each of the images based on their well name. So that when we see another well name with the same ID, what is simply telling us that, okay, yeah, we can join call photos, maybe with call intervals, and pretty much you can actually interpret that data across that particular depth. We can decide to use the depth information to do that because it makes more sense, because realistically, what they do is basically join based on depth. So I'm just going to allow you to ask questions now because I think I've just been talking too much. So in case you have questions, so ask me, please. Questions? Ask as much as you can. Can you guys still hear me?
Yes, I can hear you, sir.
Yeah, so what are the questions? I'm waiting for the question, please.
Okay, please, do anybody have a question? You can go ahead and ask.
Yeah, for Lashadi, yeah. I said check shot. Smart girl, thank you. Check shot, yes, check shot data. Correct.
Oh, good evening, sir.
Yes, please.
Yes, sir. Thank you very much for the class. I just want to know why you're not using my SQL, my SQL
It's a
workbench.
for Lashadi,
That was different.
wait, okay, did you listen to what I said initially? It's about the setup. It's the fact that we're going to spend a lot of time setting it up, you know,
Okay.
without writing a SQL, but it's still the same thing. So what I'm going to do is you can set, like you could start up your SQL. I can actually show you how you can actually do this on your SQL too. So it's not the big deal. But the problem is it's going to take a lot of time setting up that process. You know, the setup, importing data into the SQL, it's going to take a lot of time, and we will not even write a single SQL query. I'm just using this to explain what happens in the entire process. I don't know if you understand me.
Yes, I did. Thank you very much, sir.
Mm.
Okay, do we still have more questions?
Please ask as much as you can. I think it's going to be helpful.
All right, so it seems we don't have any other question. So, okay, thank you so much, sir. Mafejido just left the call, but we have Mr. Anthony on the call. So, I'll first like to thank you for your mentorship. Before we started, you came late. So before we started, each and every one of us, they dropped how the mentorship program has impacted their life so far, how it has been a worthwhile journey, and it was really encouraging. Their comment was really interesting and mind-boggling. I wish you were there. So there was a lot of positive feedback, positive comment on the mentorship program, especially how the mentor, that's how you were able to carry us along, how you were able to, teach us as a baby, right? Because most of us here, we are still new to data science, but you didn't even taught us as if that we are experts. You started from the foundation, and here we are. And the most important thing I would like to say, what made it more interesting is that each and every one of us were able to pinpoint one or two things that they don't know before the mentorship class, but since or because they were opportune to be in this mentorship class, they have achieved that, and it has become part of their life. And all thanks to you and Lecture Up. So on behalf of everybody, I want to say a very big thank you to you, sir. You have really imparted in our life. You have really done a lot for us. You have really pushed us beyond our limits, especially asking us to redo what you did. That is importing those core data. I know that was so challenging, but yes, although we have not gotten our results, we don't even know how well we did, but
I'm going
that
to send
was really okay. That was really helpful. That was really challenging, but yet it was still encouraging. We just believe we did well, and yes, so we want to say a very big thank you to you, and I will hand over to Mr. Anthony so he can, tell us on what we're expecting in the future and how our mentorship program is going to end. Yes, he's here. I think he has a lot to tell us. So, Mr. Anthony, please, the floor is yours.
Okay, yeah, thank you. Thank you so much, Ugochi. Thank you for the outstanding coordination And to our mentor, Mr. Divine.
Yeah, I can hear you. Anthony?
Yeah, please confirm you can still hear me.
Yes, I can.
Yeah, so to Mr. Divine, sincerely from the depth of our heart, want to say thank you. Thank you for choosing to go extra mile just to see to it that you're able to transfer that knowledge into us, into the people. So just want to say thank you on behalf of Lecture Hub. I want to say thank you. Thank you so much. We are grateful. Honestly, we can't really afford to pay you for this that you've done for us and the mentees. But just to let you know that we are grateful and we want to say thank you over and over and over again. And to the mentees that choose not to quit, thank you for winning. Yeah, it was at some point they said, should we not, shall we, shan't we? And finally we are here today, rounding up successfully. I want to say you're the real, is it VMPs or VMVPs? You're the real MVPs. So thank you so much. And then fortunately or unfortunately, we've done the official graduation. But if the team still want to showcase the outstanding work that the mentor has done in your life, I will have Ogochi set up that so that we can plan for a mini graduation for for this class. And I don't know what it will look like, but we can cook up something. So Ogochi, just send the message across. Let's plan for that. And then to everybody, thank you for staying. I see Samuel Ogidi. How are you doing on the other side of the world? And then to Olayemi, thank you. Mene, my G. And Ojo, thank you. I see Shaima. I see Chubeze. Thank you very, very much. All of you have been really, really great and understanding. Thank you for not allowing us cancel this class. This class, we did not finish it too. Last we finished it. So thank you to everyone. And on behalf of our founder, Ms. Sogenefe Jiro Golaga, I'm saying thank you once again. Thank you. I can't stop saying thank you, but from the depth of my heart, I'm saying thank you. Thank you to Mr. Okon and thank you to everyone. God bless you all.
Okay, so quickly, I just want to say something. It's about the guys who stayed to the end of the class. Like this is there's something I used to tell myself, during learning processes. You never know the importance of finishing something, until later in life, basically. Sometimes it's not about how well you do it. It's just about consistency. To actually tell yourself, I'm going to do it till the end. It's one of the biggest, I don't know, demarcator from those who are basically successful, both in career, in life, and also on those who are not. There's always this give up mindset. If I can understand it, if I can do it, let me just leave it. But there's the fighting spirit that comes with, when it's complicated, that's when you want to say, okay, do or die. You have no idea. Like there's no challenge you won't surmount. And that's really impressive. Most of you have, some knowledge in coding, really good. Still, that didn't deter you from still wanting to actually know some more. Most of you do not have at all, the struggle of sometimes, wanting to understand the fire part of. I see the questions on the group, I don't even know the one to answer and the one not to answer, but how you organize yourself and basically finally did the assignment, it was really impressive. And there's a lot to be learned, It's not just about what we just did, This is me just trying to open your eyes, to what is attainable, You could pick a path and pursue it. Just one path. You could be a cloud engineer, understanding cloud systems, know how to work with ACI, access controls, at least learn how to code, which is basically the foundation. Learn SQL, a lot of database, You could actually work as a data and a cloud engineer with that. Like that's a thing entirely. You can actually still pursue a career path in geoscience, by combining your analytical knowledge, to data processing knowledge. That's still fine. You could actually go into data science and machine learning, But the fundamental thing is you need to learn how to code. You need to learn how to think for yourself, and which is very important, The truth is nobody knows everything, Everybody's still trying to figure out stuff. And that's how life is. So you're here now. I don't know where you're gonna be 1 year time, 2 years time, 3 years time. So that's why, I don't undermine, people's like the people I fear the most are the people who push themselves. Those are the people I fear the most and those are the people I respect the most. That's how life is. I'm not scared of the guy who basically has $1 billion or who basically is an engineer at Nvidia today. That's not the guy I'm not because that's not the guy I'm concerned about. I'm concerned. I want to be friends with the guy who basically, with his broken laptop, there's no light. He's still pushing himself. That's the guy I am looking at, and I'm like, shit. That's the guy I'm even looking at. I'm like, this guy, this is the guy I'm scared of because if with that, level of unavailability to resources, you want to push yourself, or the guy without data still going to cafe or basically looking for ways to making sure that he's part of the process. Those are the people I'm scared of because with less resource, this is what they can come up with. What happens when they have all the resources? So those are the guys that would basically man the future, make decisions later because people see through people. Don't allow anybody bullshit you. You can't talk your way through stuff. If you don't know it, you don't know it. People will test you not just based on your technical skill. They'll test your wit. They'll test your confidence. They'll test your consistency. They'll keep testing you, especially because in fact you're even black. That's even the worst. I'm in Europe, so I know what I'm talking about. People at every point in time, before you're accepted into a system, you're being tested. To test you more than they test the white folks, obviously, because they went to good schools. So you are the guys I'm proud about. You're the guys I'm proud of. You guys are the ones I'm proud of. With the school we all went to, sometimes most of you got to learn the things you got to learn after you've left school. And you still want to push yourself, you still want to compete in the global phase, you still, put yourself together to wanting to learn. Those are the people, the world is looking for. Forget the fancy degree. Yeah, people can go to MIT or Cambridge, easy access to entering into the top companies, but you could actually grow gradually and enjoy your process and live a very beautiful life, by just doing the things you're doing rightly. So this is me trying to encourage you. It's not an easy step. I had my own challenges too. It's not all rosy. Don't get it wrong. Nobody's enjoying anything anywhere. I might have more resources now, which is basically what it is because I did my own work when I had to, and God basically helped me. But you would have your own resources in the future, and this is the work this is the price you're paying, listening to me saying boring stuff, keeping you in class while you have to wait for me, while I'm trying to run from the airport down here, sometimes, giving you assignment and making sure you do it, fighting back and forth with the leads in the class, just to get stuff done. These are the price you have to pay for this kind of stuff and pushing yourself. There are resources online. YouTube is there for you to actually use. Don't just stop here. The goal of this class is basically to open your mind to career path you can actually pursue. There's something my mentor used to tell me then in Kaduna. He used to say something. He said, there is no shortage to really good engineers or scientists. There's no shortage. There's nothing like shortage of like. So I say shortage. There's nothing like we've had enough good engineers. There's nothing like that. As a matter of fact, there's nothing like that because the point is, if you're good at something, what happens is there's always an opportunity for you. So they can't say, okay, there's no opportunity anymore. If you're good at it, there's an opportunity for you because everybody wants the best people on their team. Everybody wants to compete with the best. Like it's really crazy how the world works. You could see what's happening in the world. Look at this guy called Alexander Wang. Facebook wanted him, which is Meta, but he had a startup. He had investors in a startup. Scale AI. That company was massive. To show you how massive it is, like I did the interview. It's crazy, man. Like even one of my guy, really good guy, did the interview. Crazy. Data structure problem is not here. That company pays really well. The scale AI of then, they had contracts from OpenAI. They had contracts from like every company who was basically doing data labeling, data annotation, they had contracts. Self-driving cars company contracted a lot of like they had money. Now, what happened is Facebook wanted Alexander Wang to lead the AI team, but they can't get him because he's tied to a company. They bought the company and bought him. They say, yeah, if we cannot get, since we cannot, that's a mindset, Like there's no shortage of, if you're good, there's no shortage. And There's no, we already have good engineers. That's the one we want. Let's get the company back. Look at NVIDIA. The Trump increased their visa fee, like in terms of, they call it, I think, HB1 visa for expats or immigrants who basically are expats in US. If a company wants to hire a non-US citizen, you have to pay 100,000 grand. That's a lot of money. Companies were cutting down, layoffs up and down. But NVIDIA said, no, we're going to cover for all our engineers, because you want to, with the kind of experience and the kind of growth NVIDIA have experienced, imagine telling those engineers to go. Do you know how many companies will pay double of that amount of money just to keep those engineers for them? So it's going to be like, because at the end of the day, it's about people, driving systems, and that's what it is. So I advise you, basically to keep pushing yourself. We don't have time, like this is just me just going through, because normally you're not supposed to learn this stuff like this. This is just me trying to expose you to see what you need to know, how you need to know about it, how to, like, I'm trying to configure your thought process. This is what is happening. This is how it really works, so that you could actually start building things and learning. This should be a pathway to you looking forward to actually pushing yourself. So go to YouTube, open ChatGPT one side, open YouTube, start a course. If you cannot afford to pay for Udemy, start a YouTube course. There's 3-4 hours course. Break it down in 1 week or 2 weeks. I'm going to finish it. Sit down. The problem with most Africans is our concentration span is low. Most of us can't sit down for 30 minutes. Sit down and concentrate for 30 minutes. Keep your phone aside. Do that, like, lock yourself like 6 months and come out in 6 months' time. All you have to do is, how you test yourself is, you just realize that you just keep doing interviews and you see how you keep performing for each of those interviews. You just realize that your output is different, because now you understand better, you talk better, you see things better, you deliver better, So it's about you to it's about you to take the next step, I don't know what the future holds. Trust me, as much as possible, I'm still improving myself, I'm crazy about cybersecurity. So basically, I'm still trying to grow around that route. I've had experience in it, but basically, because I like platform engineering a lot. It's just something I basically do for the fun of it, like at the side. So I know how much amount of time I consume tutorials on Docker and Kubernetes security. So it's really crazy. So if you want to be the top 1% of the top 1%, you don't even have to be the top 1% of the top 1%. You just have to be a good, like, you just have to deliver value, Always tell yourself, I'm different. I want to deliver value. So just put yourself in that position to do that. I'm not here to advise you. I'm just here to tell you my experience and basically what I feel like you should know. So don't, you are the guys I'm scared of, with the less resources. You're the guys that are the future. You're the guys that, that would turn things around, because, you don't have all it takes to do it, but you still have to do it. You don't have any reason to do it, but you still have to do it. The government is not paying shit for you, but you still have to do it, because, you're fighting something. You're fighting for your future. You're the people where, like you're the real G. You're the guys, like, in the future that I'll look up to and say, yeah, this guy paid his sweat, and that's it. Just keep pushing. It might not come next year. It might not come in 6 months' time, but when it comes, it comes. You just realize the opportunities are crazy. If you have opportunity and you're out of school, apply for postgraduate roles, see what can happen. Study some more, apply for roles, don't be scared. But most importantly, the only way to not be an imposter is actually to keep learning. So keep learning so that you know enough. So there are two different things. People have imposter syndrome. That's because they know, but they are scared. I understand. But people have imposter syndrome because they don't even know at all. So don't be the person that will have imposter syndrome because you don't know at all. Right? Be the person that have imposter syndrome because you know, but you're just scared because you feel like you don't have the kind of academic qualifications you're competing, like, to compete with the kind of people who are competing for a particular role or for a particular opportunity. But you know what you know. So just keep pushing yourself. The sky is your limit. That's all I have to say. I hope I articulated it properly. Thank you.
And thank you so much, sir. This advice, it has really melted my heart, and I believe it also did the same to my co-mentees. And I want to say a very big thank you. Even in the chat box, a lot of us has already started saying thank you. We can't say thank you enough. Just like Mr. Anthony said, we can't say thank you enough, but we just want you to know that we really appreciate your effort, your time, your dedication towards us. All the lessons, all the ideas, all the knowledge you have impacted in us, we are really grateful. We are more than grateful. We want to say a very big thank you. I will pray that God will replenish all the strength that you have given us, because we have stressed you a lot and you never for once complain. You have always been there whenever we call. You have always been there to answer us. I want to say a very big thank you, and may God bless you more, because you're already blessed, but let God continue to bless you more and more. Thank you once again, sir.
Thank you. Before I go, Samuel has a question. You want to say something?
All right, Samuel, go ahead.
Yes, sir. Yeah. All right. Yes, sir. Thank you so much. The journey has been so interesting, and we're really happy we are learning this from you. So one thing I just want to quickly ask of is, because I don't want this to be like normal programs I've done in the past. Me particularly, that at the end of the day I just dump it. I know you've built a very strong foundation for us, so I'm just looking out for if there's any resources we can actually use to build on this, on what the basis you've shown us, so that we can actually be good at the foundation you've laid for us already. So I would like if that is possible for
So I'm
for
going to do something.
teachers.
Yeah, I'm going to do something. So by the end of this, like next week, I'm going to send three documents, PDFs, and the first one would be, a step-by-step plan, on how to be a data engineer, starting from where we just stopped. The second one will be a step-by-step plan on what you need to know to be, a practical industry data scientist. And the third one, none of you are interested in software engineering, but don't worry about it. I'll just send, a step-by-step plan on how to actually pursue a career in cloud engineering. But the trick is, if you're doing data engineering, always have cloud in your head, because most companies want someone who has, knowledge of cloud resources and also know how to basically build pipelines. If you're a data scientist, they want you to model, classify, keep iterating, extract, transform, load. So I'm going to just create 2 pathways and send to you so that you could actually just keep learning, just do as
All
much
right.
as you can. And that's all I can say for now. Just do as much
All
as you
right,
can.
sir. Thank you so much, sir. The third one will also be very, very good, because fortunately, let me say, I found myself in the midst of a software developer in my team. So I found that most of the thing they are saying is kind of off for me. So including the third one will also be of help for some of us.
Don't
Thank you,
listen to
sir.
them. Software engineers are software engineers. Sometimes they just want to make things complex. But if you look very well, what they're doing is basically 2 things: pulling data from database, pushing data into databases, and interacting with user interfaces. So they're not doing anything very, 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 very superb. If you're a data engineer, you can actually do the role of a backend engineer. All you have to do is basically learn how to write clean codes, just the way software engineers write it, especially when they want to push code to production. So if you're a data engineer, you're a software engineer. In fact, some companies, the rules are blood. They say if you're a data engineer, you're a backend engineer. That's what it is. Except you want to pick up front end, which basically I'm not the guy for you most time, because sometimes I build, like when I work on projects, the role is backend engineering, but what I do is basically, just push data from different databases, play with APIs. That's what I basically tend to do. So you can be like a software engineer and a data engineer. It's just blood role, because now every company is building data products. What they want to see is basically how they want to pull data, how customers interact with data, how clients interact with data. They just want to see that process. So I think if you could actually spend time mastering, data engineering, especially, developing pipelines, you're good. You're good. You don't have to worry yourself. You could actually, like most of the people I work with, if they change role, they become software engineers in another company, because those companies do not have data engineering role. So it's just software engineering role available. They just software engineer. And basically you might just be managing one small infra, nothing special. But I think in Nigeria, what happens is everybody builds everything. You build from start to finish. So it's really difficult to actually know what you're doing. So the guy is a UI guy. At the same time, he's a backend guy. It doesn't work that way. So pick a stack and focus on it. That's what I advise you. So if you want to be a data engineer, I think it's a very fantastic place to be. If you want to be a data scientist, I'm going to give you practical steps, things to learn that, you can use. Forget about the hype. When it comes to practical work, there are things that still work. I'm going to give you, in fact, basically including LLMs and how you can actually use them. So there are things that actually work and how you could actually use them. But for now, you have, I think, I think for you, Samuel, I think you're more inclined to, the software engineering part. But one thing I would advise everybody to do is basically take out time to learn SQL. It's going to help your life. Learn SQL as much as possible. SQL and Python, just marry it for the next 2-3 months. You don't have to be an expert Python programmer. You don't have to be an expert SQL. Learn it enough that you can see a problem and you can tackle it with Python or in SQL. If you're going towards data science, I'm going to tell you what to learn. Pandas, NumPy, classical machine learning using scikit-learn, and neural net. The point is, there's always a lot of things to learn. So you have to basically narrow what you want to do and how you want to do it. So I don't know. You might get this advice different from a different person who sees things differently. But at the end of the day, what happens is people want people that solve problems. So if you're not solving problem with this, you're just learning tech stacks and just dropping it. So you pick a practical problem and solve it from start to start, end to end, for someone to use. And that's what makes you, an engineer. So that's what it is.
All right, sir. Thank you, sir. Not really into software. I just happen to work with a team of software on a project we're working on. So it's more of LLMs and AI stuffs that I'm much inclined to.
Nice.
Yes.
Nice. Okay. I would send that document, by the end of the weekend, just, and if I were you, start thinking of problems you want to solve. There are a lot of problems, but like for especially those of you who are just finishing school, so that to help you learn, and improve your portfolio when you're talking to someone. It's easier when you go to someone and say, okay, this is what you've been working on, this is what you've been doing, and this is how you did it. And the depth of your technicality would actually make the person listen to you rather than saying the person, I'm looking for a job. Are you getting me? Have a conversation. Then at the end of the conversation, you say, if for any reason there's an opportunity, that's how you network with someone, just make sure you're working on something so that you could always have something to talk about. So when you go for conferences, that's the way to do it. If not, people will just, just let another graduate looking for a job, You know how they make mockery of graduates. Don't be like that.
All right, sir. Thank you so much. And thank you, everyone. So we have come to the end of our mentorship program. And on behalf of Lecture Hub, I want to say a big thank you to everyone. And yes, I'll be reaching out to the coordinators. So I'll be getting feedback on if we are going to do the project and also how our certification is going to go, right? So all of us, we have to stay in touch. We have a group already. So if there's any information, I will always drop it in the group. I think that's all. Thank you so much. And thank you so much to our mentor once again.
Okay, let me let you guys be. Don't be shy. You could always drop me messages, LinkedIn. If I don't reply, I will definitely reply. I promise you. I wasn't around. That's why most of the messages I didn't reply on time, but I'll definitely reply. I wish you guys all the best, and I know in the future we're gonna meet somewhere, and we might be building something together. We might be working on something together. There's a lot of problems to solve in Nigeria and all over the world. We might even be on the same team. Who knows? And you'll be like, Divine, remember me? Yeah, I work here now. I'm like, oh, good. So we're teammates. It makes life easy for me. So just keep your head down. Forget about the noise. Don't listen to people. Nobody can tell you how your life will turn out to be. Just keep your head down. Always invest in yourself. Focus on what you know, what you learn, how you intend to network with people. Be respectful. Be humble enough, and most importantly, just pray. It works. All the best, guys. See you some other time.
All right, so bye.
Okay, bye.
And to the rest of the house, have a good night rest. Thank you.